Hey guys, in section 2013, we're going to learn about two different kinds of molecules, or two different classes of molecules, called aldehydes and ketones. And one thing they both have in common is this double bond between a carbon atom and an oxygen atom. And this double bond is common enough in organic molecules that it's been given its own name. As you can see, it's the carbonyl group. It is the functional group for ketones, and it's part of the functional group for aldehydes, esters, and carboxylic acids. So it comes up fairly often. It's a very common component of organic molecules. Now in this picture, you've got the carbonyl group right here. There's also R and R prime. These R's stand for the rest of the molecule. Now, some sort of a substituent like methyl or ethyl or propyl or even phenyl that you're going to stick on here. Again, you can think of these almost as Legos, where this carbonyl group is a Lego piece, and you can attach another piece on the left side and another piece on the right side. R prime could be the same as R. There's no rule in the universe saying it can't, but it can also be different. And so that's why it's got the prime to indicate that it may very well be different. In this picture, yellow does not represent a particular kind of atom, it just represents an R group. Now, this is a little confusing perhaps because it looks like a single atom. The R groups are generally not a single atom. Technically, it could just be hydrogen, but more often than not, this is a collection of atoms, right? And so where you see these yellow pieces, you want to keep in mind that these could be a few atoms, it could be many, many atoms, and there is a chance it could just be one hydrogen. So here's the difference between aldehydes and ketones. Here's the carbonyl group. That's the functional group of a ketone. Here's the carbonyl group with a connected hydrogen, and that is the functional group for an aldehyde. Now what this means is that the ketone is going to have its functional group in the middle of the molecule because there's going to be one piece coming off the right and another piece coming off the left. That's not true for aldehydes. Aldehydes always have their functional group on one end of the molecule because the hydrogen here stops the molecule. Hydrogen can't bond to anything else, so this is necessarily the end of the molecule, right? Let's look at some examples. All of these molecules are ketones. Here's the carbonyl group, the functional group, and you see it again over here, and you see it again over here. And what you notice is that the R groups can be symmetrical. Here it's a methyl, and over here on the right side it's also a methyl. In this molecule, the R group is basically a phenyl, and then here is another phenyl. Technically there's another carbon coming off of here, but these big benzene rings, when they're used as substituents, are called phenols. Now here the molecule is not symmetrical. We've got a methyl group on one side, and then we've got this vinyl group on the other side. I'm trying to think if there's anything else to say about this. This molecule is a little bit interesting. It's called acetone. It's the simplest ketone. And you've heard of acetone. It's nail polish remover. Sometimes it's also called paint thinner. You can go to a store like Runnings or maybe even Walmart and find a bottle labeled ketone because this acetone or this ketone is very good at dissolving other things like paint or nail polish and so forth. Here are a few examples of aldehydes. So again, let's find the functional group, the carbon double bonded to oxygen with the hydrogen on one end, right? So there's the functional group. The R group in this case is a single hydrogen. In this molecule, the functional group is right here. In this case, the R group is methyl. Here's the functional group of this molecule. In this case, the R group is ethyl. And here is the functional group in this molecule. And the R group is enormous, right? So what are these things? Well, this is formaldehyde. If you've ever dissected anything in biology, um, formaldehyde is often used to sort of make the dead creature, I don't know what the word is you would use for it. It sets it so that it's not just a big pile of gore and putrescence. The formaldehyde keeps it from being decomposed. This is technically called methanol. Pardon me, ethanol. Forgive me, this is ethanol. This one could be called methanol. And then this is propanol. And this right over here, I believe, is cinnamaldehyde, which is the molecule that gives us cinnamon. If you like cinnamon, what is just extraordinary is that this collection of molecules, there's a few dozen molecules there, pardon me, a few dozen atoms, this tiny molecule can cause emotional responses in human beings. When this gets on your tongue, if this gets into your nose, it triggers a whole set of reactions in your brain that maybe it stimulates some sort of a memory, maybe it makes you feel good, maybe it makes you feel bad, maybe it makes you feel hungry, maybe it makes you feel sick to you. Who knows? But it stimulates a response in many people. So these are examples of ketones and aldehydes. You should be able to identify their functional groups. You should be able to identify their R groups. And you should know a few common examples like formaldehyde, like cinnamaldehyde, and like acetone.